So for today's, I'm going to tackle the human brain. The brain is the most complex organ of the body. In the surface of it is the cortex, and usually called gray matter. It is consisting of billions of neurons, nerve cells, and glial cells that is supporting and protecting the neurons. Cortex is the decision-making organ of the body that receiving messages from all the sensory organs initiates all voluntary and involuntary actions, and in the storehouse of our memories and seat of our consciousness. That is most distinguished between the human and animals. Brain is composed of the right and left cerebral hemisphere, joined by the corpus callosum. Corpus callosum is allowing the right and left hemisphere of the brain to communicate with each other. Generally, the left hemisphere controls the right side of the body, and also the right hemisphere controls the left side of the body. Left hemisphere is responsible in human action. A sensory information from the right side of the body is received by the left hemisphere of the brain. Same goes by the left side of the body, and the right hemisphere receives the other. It is referred as contralateral brain function. Let's move on to the localization of the brain. Theory of localization proposed by Franz Joseph Gall, which is the idea of the different human cognitive abilities, and various are localized in the speech parts of the brain. Some Gall's view are amusing. For example, he proposed that language is located in the frontal lobes of the brain because as a young man, he had noticed that the most articulate and intelligent of his fellow students had portraying the eyes which he believed reflected over development brain material. He also supported a pseudo-scientific theory called the organology that later became known as phrenology. Phrenology is the practice of determining personality traits and examining the bumps in the skull. Let's proceed to aphasia. Study of aphasia has been an important area of research in understanding the relationship between brain and language. It is the neurological term for the language disorder that results from acquired brain damage or disease and trauma. In 1860, the French surgeon Paul Broca proposed that language is localized in the left hemisphere of the brain, in more specifically in the left hemisphere that is called now as Broca's area. Broca's finding was based on the study of his patients who suffered from language deficits after brain injury to the left frontal lobe. Decades later, Karl Hernix, a German neurologist, described another variety of aphasia that occur in the patients with lesions in areas of temporal lobe, now known as Wernicke area. Literalization is the term used to refer to the localization of function to one hemisphere of the brain. Language is lateralized of the left hemisphere, and the left hemisphere appears to the language hemisphere of the infancy own. So let's proceed to the linguistic characterization of aphasic syndromes. Patients with injuries of Broca's area may have Broca's aphasia, and Broca's aphasia is characterized to be labored speech and certain kind of word finding difficulties. The most notable characteristics of Broca aphasia is that language produces often grammatic mass that frequently lacks articles, preposition, pronoun, auxiliary verb, and other function words. Broca's aphasias are typically omit inflection such as the past tense suffix ed or the third person singular verb, English with s. Here is an excerpt of conversation between patient with the Broca's aphasia and doctor. The doctor says, "Could you tell me what you have doing in the hospital?" The patients reply, "Yes, sure. Me go PT, which is the physical therapy. Continue. 2 times read, write, Right, alright, practice getting better. The doctor replied, and have you been going home on weekend? The patient replied, why, yes. Thursday, uh, uh, no. Friday, war, ba, ra, wife, and car, drive, pie, rest, and TV. That was the conversation between the doctor and patients of the Broca's. Broca's aphasics, also often called agrammatic aphasics, may also have a difficult understanding in complex sentences that their comprehension depends exclusively on the syntactic instruction, where they cannot just rely on the real words knowledge. Unlike another example is from a patient who was a physician before his aphasia. When asked whether he was a doctor, he replied, me? Yes, sir. I'm a male demoplos on my own. I still know my thoughts of boys. What for? I have that's gone hell and some of them. Go. The linguistic deficit exhibited by the people with Broca's and Wernicke's aphasias point to a modular organization of language in the brain. Damage to different parts of the brain results in different kinds of linguistic impairment. This supports the hypothesis that the mental grammar, like the brain itself, is not an undifferentiated system, but rather consists of distinct components or modules with different functions. Unlike Broca's patients, people with Wernicke's aphasia produce fluent speech with a good intonation, and they may largely adhere to the rules of syntax. However, their language is often semantically incoherent. For example, one patient replied to a question about his health with, I felt worse because I can no longer keep in my mind from the mind of mine to keep me from mine and up the ear which can be to be found among ourselves. So, another patient described a fork as a need for a schedule, and another, when asked about his poor vision, replied, my wires don't hire right. People with damage to Wernicke's area have difficulty naming objects presented to them, and also in choosing words in spontaneous speech. They make numerous lexical errors with substitutions, often producing a jargon nonsense. Words. Split brain patients have shown when interhemispheric visual connections are severed. Visual information from the right and left visual fields become confirmed to the left-right hemisphere. Because of the crucial condiments of the left hemisphere for a language, written materials delivered to the right hemisphere cannot be read aloud if the brain is split, because information can be transferred to the left hemisphere. So let's go to decotic listening, an experiment technique that uses auditory signals to observe behavior. Subject has two sounds signaled through the earphone. It can be heard curl in one ear and girl in other ear, like cough in one ear and laugh in the other ear. When asked to state what they heard, each ear subjects are more frequently correct in reporting linguistic stimuli delivered directly to the right ear. Both hemispheres receive signals from both ears, but the contralateral stimuli prevail over the ipsilateral, same slide, stimuli, because they are perceived robustly. The contralateral pathways are automatically thicker. The contralateral pathways are anatomically thicker and not delayed by the reed to cross the corpus callosum. the corpus callosum. That was all. The corpus callosum. That was the last part of my topic. Thank you for listening and watching.